Start streaming, and we are now live from downtown Mill Bay. And pull out your, put away, once you've got your stuff entered, put away your laptops, pull out your notes, and pull out your review work. I believe we're starting with sheet 1. Why is that open? We don't need that. Let's get rid of that. There we go. Okay. If you happen to see Dylan Markham, please thank him. He volunteered to upload all of his work, so this is actually his work that we're marking as we go along, and had it corrected in front of the entire class. First section, we are looking at sig figs. Just so you're aware how, now sig figs in Chem 11 apply to every single question you did. And there was marks associated with it or proficiency associated with it that you did it. In Chemistry 12, it works a little bit differently. On any particular assessment, I will pick one question, and that is the question I check the sig figs on. I don't check any of the other ones. The caveat is that you don't know which question it is. But if you're not doing sig figs that well, you only get dinged once. And we also don't give you any extra marks or proficiency for having it there. It just should be there. If it's not, you drop a proficiency in that one question. That's it. Standard to what we did when we had provincial exams. We don't want to kill you on sig figs over and over again, but you do need to pay attention to it. And later on, when we introduce logarithms, there's a special sig fig method that we use with logarithms that we'll teach you, and that's on your final, what the sig fig question will be on. First of all, then looking at molar mass, adding them up. When you're adding things, you go by decimal place, and so it wouldn't be 2 sig figs. You'd go that it's in the 0.1 place, and so it would be 3 sig figs to 16.0, and we'd be going to a decimal place here, so it would be 149.0. Yes, sir?
Grams per mole is right.
Grams per mole is absolutely right. It depends on how you've previously been taught, which is weird because I taught Dylan and he should have written grams per mole. But some chemistry will teach us and say molar mass is the grams in 1 mole. So if you write down grams, it's already defined as per mole, so it's fine. But if you use it in calculations, you want grams per mole. How many moles in 288.9 grams of Na2CO3? We need to get the correct molar mass. You don't have to worry about sig figs too much as long as you get the final sig fig correct. So this one's technically 4, this one's 4, which means as you go through, it should be 2.725 or 2.726 moles, depending on how you rounded necessarily as the final answer. Yes?
On ours it says FeNO3.
FeNO3?
Like on the review.
I didn't hand out different things per class.
Last question, period.
That's question 3.
Oh, okay, sorry.
Oh, there we go. A momentary panic. If I handed everybody else a different sheet, I'm like, I have to get those up here. And I would have to start working on those. Yeah, there we go. What is the mass of 0.157 moles of the substance? You need the molar mass. Add them all up, 241.3 grams per mole. Multiply those together, moles cancels. You end up 3.80 grams. 3 sig figs, 3 sig figs. Yes? 3.79 will work. Whenever I'm looking at your answers, I am going to look, are you within what we would consider sig fig error? So this sig fig error means plus or minus 0.01. So if you're 3.81, 3.79, you're always good. If you're way off of that, what you have done is round probably in between calculations. Never round in between calculations, or if you do round way beyond the sig fig, so take it a couple extra. You only want to round at the very end. Practically speaking, if you have a multi-step problem and you round at every step to the sig figs, you are introducing consistent error into your results. So you don't want to do that, but that's fine. 4. What is the molarity of the solution made by adding 2.56 moles of K2S to make 10.0 liters of solution? You've got a molarity, you've got a liters, concentration is moles per liter, so you just add the, take the units and divide them to get moles per liters, 0.256.
Does 0.26 work?
0.26 is the incorrect number of sig figs. It's the right answer, it's just the wrong precision. So you need 3 sig figs. The 0 in front of a decimal doesn't count for sig figs.
No, doesn't it work so like the amount of decimal points you have after?
Yeah,
Isn't that how many sig figs you have to have?
roughly. Like this is
No,
3
'cause,
sig
like,
figs,
2.6 would be
2 sig figs.
0.26. That would be 2 sig figs.
Yeah. But how many would this be?
3.
3. Okay, good. You're counting them right. Questions on the first 4? 5, MgCl2. We have a calculation. First, we have to convert it and the liters and the moles, 0.48 moles times by the mass. Now, this one should be 2 sig figs. And you end up having 46. Not sure he did the rounding there and then he just expanded there. Not sure why he did that, but. And then of course the molar mass there. 6. Lithium, 6.9, 35.5, 42.4 grams per mole. Take the mass, divide by the molar mass, you'll get the number of moles. Now, this is something, I mentioned it there, I didn't, there's no equal sign in between this. It's like this happened. Where's that number? For those of you who did that. Yep.
The 1.7.
1.7. You just wrote it there, and it implies sort of like that's equal. But he never actually said that's equal. You kind of need to take different steps. The reason being, does this side equal that side? No. So just be explicit about your steps. It's a very common thing for students to do that, where they'll do that, let's say equals this, and then you just continue on with the calculations. But mathematically, it doesn't make sense because those two sides aren't equal. So be careful that you're showing your steps in a way that is also mathematically consistent. That becomes more important as you go up in senior sciences, and you have to justify your work to others, particularly if you're doing actual labs. Next one, you didn't need the molar mass at all. You just took 0.4, use the stoichiometry 2-to-1 ratio, divide by 1 times by 2 to get 0.8. And of course, you didn't have to use the table method. You could have just 0.4 moles H2 times 2 HCl over 1 H2 equals 0.8. That's written kind of badly. 0.80. Let me just rewrite that. 0.80 moles. And so either one of those methods is, of course, fine. 8. Divide by 2, multiply by 3, a little bit harder of a stoichiometry in recognizing the 2 to 3 ratio. You can also calculate it out like this, where you say I have 1.7 moles of NH3 times 3 hydrogen gas divided by 2 ammonia, and you get 2.55 moles of H2. Table method, calculation method, all is fine. Start off with 2.5, you end up with 5 moles. It should be 5.0. It should be to 2 sig figs, but other than that, this is well done. If I'm going too fast, slow me down. If you need to check your work. Oh, so for number 8, you start off with 1.7, right? So when you move from one spot, do you use the table method last year, or did you use a calculation method? Table. So you divide by the column you're in, so you divide by 2. Multiply by the column you're going to, so you divide by 2, multiply by 3. So you multiply by 3 halves, and you should get 2.55. Some nods. There was no converting to mass or anything with that. We were here. Now, this is one in which he had an error, and I like this error. I'm going to erase this so you can see the mistake that he made. because it was very nice of him to let us see this, in that this is a really common thing. I find when we put the molar mass, some students will look at that too, and then they'll double the molar mass. And you don't double the molar mass. It's 23. Just because we need 2 sodiums doesn't mean the sodium becomes twice as heavy. The stoichiometric ratio is just based on how much you need. It doesn't affect the fundamental properties of the element. If you invite someone to dinner and you're cooking a certain amount of food, and then you invite 2 people to dinner, the food doesn't become magically twice as heavy. You just have to buy twice as much food. And so the same with the sodium. The molar mass never changes. It doesn't matter what number's in front of it. It is a fundamental constant on that. And I know that's an error that I would see a lot in Chem 11. And it's a very easy one cognitively to make because it affects so many other things. So just be aware of that. Interestingly, I don't think... Oh, it was a 1 there. That's why I didn't do it there. So we got the moles. We jump over with the moles. And then we use the molar mass to jump down to there, except to using the correct molar mass, we get 0.465 grams. Questions about 10? Yes.
I took the 1.62 grams and then like converted it to moles using its molar mass.
Mm-hmm.
And then, so I can't double the moles because removing, like from sodium, removing,
So you got 0.0101?
I got the same thing, I got 0.939.
So that means you had 46 for the molar mass, didn't you?
I'll just go over.
If you got 0.929, at some point you doubled something.
Yeah, I doubled the moles from bromine to sodium.
What were the moles of bromine?
0.02.
0.02? What was the molar mass of bromine?
Yeah, at 79.9.
79. Oh! So it's not that you doubled something, you have something. Bromine is, there's bromine. Is 79.9, but that's Br2. No, in the question, it's bromine gas. So there are 2 bromines, so you have half the number, you have the molar mass is just half of what it should be. So you end up getting double the amount of moles. Make sense?
Yeah.
Okay. Then some light excess reagent problems. These are in 1-to-1 ratios or 2-to-2 ratios. They're fairly easy to compare. Then you can look directly at them and say, which one do you have more of? Well, look, I have more of this one. How do you know that you have more of it? You actually have to show the calculation. So in some way show, look, if I minus them, this is how much I'm going to have left over. I'm going to have that left over at HCl. If I have 2 liters of it, then I take that, divided by 2 liters, and then I get the moles per liter. So that's the answer to A. That's the answer to B. Good. Review sheet number 2 to determine the number of sig figs. For question number 1, it's 5, 4, 3, 5, 3, 7. And I'm perfectly happy to redo any of those. This one caused some problems because I think this is F, because you don't count that 0. That's bad. You don't count that 0. But at the first decimal, you count that, and you get 1, 2, 3, 4, 5, 6, 7. And they count all the way to the end because you measured all the way to the end. That's what that 0 is telling. Question about number 1? All good? Question number 2, convert to scientific notation. And I ran into this in a couple of people. there was the assumption that scientific notation works like this: x dot xx times 10 to the n, and that you were only allowed 2 decimals. I was like, that's weird. But more than one person had that error, so it must be a thing that crops up somewhere. You can't, if you're given a number, you can't cut off the number. You have to include the whole number. So the answer to D is 1.2345678 times 10 to the 6. That got erased. Calculations. Can you do sig figs, and can you do simple unitary analysis? Centimeters times centimeters gives you centimeters squared. 2 sig figs is the smallest amount, so this should be 2 sig figs. 3 sig figs times 5 sig figs gives us 3 sig figs. Grams per mole times mole gives us grams. We've got 4 sig figs times 3 sig figs, so we should have 3 sig figs in our answer. Liters times moles per liter gives us moles. And grams divided by grams per mole gives us moles. And a reminder, the reason for that, if you take the reciprocal, yes?
It's about sorry, question 2.
Oh, yeah,
You're saying
go
you
back.
can just cut off a number.
Yeah.
But if it's, say you like, can only have 3 sig figs.
Oh, then you cut it off. Absolutely, yeah. It was just, you can't get, if you
Yeah,
just
yeah,
give it,
just
you
cut
can't
it.
just get tired of writing the number. Yeah, yeah. And there were some people who thought you always cut it off at 2. I think that
You would round. So if it's like,
you'd round, yeah. So if you were to round, say, here, it would be 1.235. If you were to round here, it would be 1.23. Is that a math rule? Stop after a certain number of decimals still in senior math courses? Like we only want answers to 2 decimal places? Some of you are nodding. I think that's maybe where that earlier one came from for some. Oops. Where was I? Oh. Grams divided by grams per mole. Just a reminder of how reciprocals work. That is equal to moles. The reason that's equal to moles, if you take the reciprocal of something, so I take x and I take the reciprocal of it, I get 1 over x. But if I take 1 over x and I take the reciprocal of that, so I got 1 over x, what does that equal? X. So things that you take the reciprocal of flip. So if the reciprocal of x, I get 1 over x. If you take the reciprocal of 1 over x, I get x. So if I have grams divided by grams per mole, grams cancel, and I essentially have 1 over moles. Moles flips to the top, and that's why you get that final answer. 3 sig figs, 4 sig figs are answered to be 3 sig figs, and meters times meter goes to meters squared. Good. Aluminum doesn't have Roman numerals, and it doesn't matter if it's aluminum or aluminium, depending on your pronunciation. This is one of the few cases in which if you are English and you say aluminium, you are wrong. The IUPAC method is aluminum, but aluminium is recognized as a common way to say it. That they're actually wrong. And weirdly, it's because the Americans were doing what the British did. So it was named aluminum. It was ratified by the International Union of Pure and Applied Chemistry. The Americans called it aluminium. They were corrected. They started using aluminum. And then the British stopped using aluminum and switched to aluminium to make it sound the same. And it's never gone back the other way. So pronunciation for chemistry is defined by the International Union of Pure and Applied Chemistry. And it is aluminum. It's the one area I can say English is not defined by common use. Aluminum hydroxide led to nitrate, iron 3 chloride, sodium bicarbonate. It can also be sodium hydrogen carbonate, potassium thiocyanate, monohydrogen phosphate. I think that's also diphosphate on your sheet if you did that. There is no such thing as diammonium. It was doing something fancy there. Magnesium acetate and sulfuric acid. Sulfuric does not matter if you spell it with an F or a PH. Those are both recognized by the International Union of Pure and Applied Chemistry as being correct. Good. Should ask before we move. Anybody still correcting? Okay. Chemistry 11 review. Ammonia. Acetic acid has a bunch of other names. You could have also called it a vinegar, or you could have been really correct and called it ethanoic acid. FeO, Na2SO3, NH4OH, K2Cr2O7, potassium dichromate. That's pretty useful stuff. You can blow up things with that. Cobalt 2 chloride, SNS2, SNSO4, methane, CH4, hydrochloric acid, HCl, and hydrobromic acid, HBr.
Should go back up.
Yep. There. Last year, there were 3 compounds I think you just had to have memorized. That's ammonia. That's methane. You can also say methane, but I'll make fun of you, like the people who say microwave. And H2O is water. Yes. Okay. Any objections if I scroll? Reactions, you need the state symbols. So magnesium chloride, aqueous, AgNO3, aqueous, which is 2 in front, so they also need to be balanced. The solid is AgCl. The solid here is PbI2. Everything else is aqueous, balanced. HCl plus MgOH2 gives MgCl2 plus H2O. So acid plus base gives salt plus water. Acid plus base, again, H2SO4 plus KOH gives us our salt, K2SO4, and water, H2O. H2O should be a liquid. Water cannot be aqueous, because it is the thing that makes other things aqueous. Good. Excellent. Chemistry 11 review. There's a little bit of stoichiometry in this one. Same error happened here where because of the 2 in front, he doubled the molar mass. But other than that, it was done correctly. Also, this gives me a good chance to discuss your answer. One of the reasons I liked using Dylan's and he gave me permission to use is that all his calculations are very well laid out. I can see every step that he's doing. He includes all of his units. Right from up here, you can see everything that's happening. And that makes it very clear to see your own areas when you're doing practice problems. And so we need to see all of your units because your answer doesn't really matter. It's your method. And Dylan's method here is entirely correct. This is almost perfectly correct. He just doubled one thing when he should have. That's one error. I can see that, and everything else is good. If you only put the answer down, I don't know what method you used. And if you put the right answer down and use the wrong method, it's entirely incorrect. The right answer with the wrong method is incorrect because every other time you use that method, you will be wrong. It's actually more dangerous than just getting it completely wrong. Because if you get it completely wrong, you know you got it wrong. But if you have a method where you once in a while get the right answer, then you'll keep using that, and that is incredibly bad. You'll then learn to do it incorrectly and get it routinely wrong. So we want to make sure that you're trained up properly. The method you use doesn't matter as long as it's a method that will arrive at the correct answer, though. And there's always more than one method. So if you don't use the table method, don't worry, that's fine too. Okay, once we corrected that and we had a different mass, and we had 2.61 moles, times by 2, 5.22, multiplied by the correct molar mass of 27, we get 141 grams. For new students, last day, did I say the washroom policy? If you're a new student, my washroom policy is that you're in grade 12. You don't need to ask me to go to the bathroom. That's ridiculous. On the other hand, if you are going to the bathroom for half an hour, that's also ridiculous. You need to come back here. So please, if you're just going to go somewhere for a long time, like the health center, I need to know where you are. But if you leave without telling me anything, I'm assuming it's a short bathroom trip.
Can you go back up?
I would just ask that you not take your phone, because it's one thing to need a short break from class. It's another to get distracted on TikTok and see someone who's way more entertaining than I am. Good, Gleb? Question 2, another stoichiometry problem. Again, I gave you a 1-to-1 ratio, so you didn't have to do anything. Now, if these were in a different ratio, it probably would have been useful to set up a limiting reagent row and figure out which one was limiting reagent. But given they're in the same ratio, you can just compare them directly, minus them, and get the amount of excess reagent, which is NaOH, because you have too much of it. So NaOH is in excess by 1.53. If you have 4 liters at the end, then you can calculate its concentration by moles divided by liters, and you get 0.38 moles per liter. And I think that's the last one. Now we're going to hand some things out. You can put the review work away. I'm not going to take it in. Also, there's somebody filming it here. I'll mention that part. Now your brand new Heftons have not yet arrived. So I have photocopied the first 6 pages or so. So you will get a textbook that has this in it. You're going to be assigned some practice problems. These are the part of the textbook and the practice problems for right now. The answers are not here, but I will post the answers on the Google Classroom so that you can get those as well. So these can just go in your book for now, and then eventually you'll be able to shred it. Hopefully the textbooks come quickly. If you see anybody in AP, you could growl at them for them, because the reason we don't have our textbooks is that AP decided that our regular Chemistry 12 textbooks were so good, they are also going to use them, and they stole them. And also I like Miss Carroll, so I wasn't going to take them back. The answers aren't online. Oh, you mean that particular section is not online? I could probably make it online. And if I don't, you could email me and bug me incessantly and tell me. At the beginning of the year as a host parent, I find I have a lot of things to do, so I just don't forget things. So email me if it doesn't get done, and I'll know what to do. I'm now going to give you a book. This is free. I'm not going to charge it to you. It's paid by your tuition, which is probably expensive enough. Only the first one's free. After that, you need to get them. But you do all of your Hebden work. So the sheet I just handed you with practice problems, all that's done in here. Write Hebden on it, write your name on it. Do not write notes in this. The reason you don't write notes is I will take it in periodically, and I will look at it. If you write notes in it, then while I have it, you don't have your notes. And I don't want that to be the situation. You'll tend to hand it in during an assessment or a test, and I'll take a look at it and see where you are. Because you have the answers, however, I am not marking your answers. For anybody who's new and hasn't seen this practice before, I'll hand them out right now. Put your name on the front, put Hebden on it, decorate it, use sparkles. 1, 2, 3, 4. 1, 2, 3, 4. And I do that perfectly. 1, 2, 3, 4. Now it's not posted yet, but I will post an Excel sheet or a Google sheet that lists the minimum number of questions you need to do as practice problems. And so when I look at your book, one of the things I'm checking is that did you at least do the minimum? The minimum isn't extending high or anything, it's just that did you do the minimum is sort of like the minimum. If you've done the minimum and there is just the answer there, which means you probably could have copied it out of the back of the book, that'd be like a developing. What I'm actually looking for is that it's a study book. So you've done the questions, you've written them out completely, you've canceled units, and if you get them wrong, don't erase them. If you want, lightly cross them out. I want to see corrections, so they should also be marked. And then explanations written on the side, that would be fine as well. I'm looking for signs that you're using this and learning from it. So I'm not marking your answers because you'll have the answers. You practice. I am marking your communication skills. Are you using this in a manner that's effective for studying from? You need to do practice in order to get better at content, but I'm not marking that part because you need to practice it. That part's formative. As an example, now these are just 2 from last year. There could be someone in this room, I don't know the name of them, so. This is an example of a really good one. This is a non-calculation section. So these are obviously questions where it's like, what are the types of molecules? That's an ion, that's a molecule, that's an atom. You don't have to write out every question. That would be a waste of time. But they've corrected their works. When they said it was heterogeneous, they wrote up that it's homogeneous. They can go back and review that question if they need to for a test. They've got explanations here, true solutions and components, da-da-da-da-da-da-da. And they've written out why they got that wrong and what they should know for next time. So there's some really good corrections in here. It's quick, it doesn't have to take a long time, but I can see that they're going through it. They're not just copying the answers, they're not just check marking or Xing, they're also trying to figure out what it is they did wrong and what the right answer is and why. So that's a perfectly good one. For one that has a couple of calculations on it, they're laying out their work nice and neat. You can see all of their work. Where they've done it incorrectly. Why does that have a blue line? I must have been making a point there. And they're saying why they got that one in particular wrong. They got stuck at a particular point. They have a reminder for next time of what they're trying to get. They have a correction from the problem. And then they have a note here, which I quite appreciated, that they did get it eventually, but they got it right with help from the book. So they looked up the answer. They tried to work it backwards. Never correct your work by doing a question, checking the answer, doing a question, checking the answer. You will not learn very effectively that way. It'll be a slower method. I mean, you will, but it will take longer. Do a section. Do 10 questions, do 15 questions. Once you're done a section, then check all of them. That gives your brain time to forget a little bit, and then go back and really check your work. If you check too quickly, you will fool yourself because your brain is really good at making up a story as to why you got it wrong. And you go, oh, I got it wrong, but because I was just thinking about it, I actually kind of knew that. And so I didn't really get it wrong. You just won't have that same sort of like, this was actually the way that it should be done. So a couple of examples of what a good Hebden looks like. So I'm not looking just that you have your answers there, but that you are actually using it as a workbook. Questions about the Hebden? Excellent. Okay. We'll start a little bit. How much time do we have left? We have a little bit of time. We can start on our first bit of Real Chemistry 12 till 10:35. We've got 15 minutes. That's more than enough time. Worksheets overall. There we go. And that one. Whoa. So pull at this and pull that one away. Oh. And stop showing me stuff. And $2012 F block. Oh. Why didn't that work? There, that worked. Okay. Sorry about that. That wasn't properly connected. There we go. Gonna go with 12 randomly. Max, give me an example of a chemical reaction that occurs at a rate. And I'm going to ask someone else the same question. So I sprung that. Magnesium and water. How fast does it react? Fast. Reason. Fast. Now, someone else, an example of a chemical reaction that either reacts faster or slower than that. And for those who are new, what I do is I have a magic app on my phone and I press the random button and then it calls someone. So that way I'm not presenting my own personal biases and like only asking the people here because I'm right-handed or something like that. So, Davis.
Oh, me?
Yeah.
What's the question?
Well, the question is, can you think of a reaction that reacts either faster or slower than that? If you leave a piece of steel outside overnight, what happens by the next morning? It rusts.
So steel and water.
Yeah.
I
Steel.
guess that would be slower.
That would be slower. And that one's slower. So reactions occur at different rates. This is the study of kinetics. Kinetics is the study of the rates of reactions. Oh, now that everybody's returned from the washroom, I should say the thing I was going to say before. I've asked you to put away the review. I obviously didn't take it and mark it. I'm not going to mark it. It's review. Completely independently and unconnected to that in any way whatsoever, any particular class can start with a brief 5-minute quiz, 5 to 10 minutes, on the previous day's material. So next class, the only previous material would be the Chem 11 stuff. Not that I'm saying that it's connected, but it could. It could.
Should we rate this in a...
Sorry, should you write what? So, kinetics is the study of the rates of reactions and the factors which affect rates. I know that none of you will have problems reading my writing. I have been told several times I should become a doctor. But if you can't understand something, I can try and identify it for you. Although if a computer can read it and you can't, I will mock you slightly. What? The study of the rates of reactions. Look at that. Look at that. Oh. Okay, fine. One word.
The word after steel. No, but identify it. That is not what you think. Steel rusting.
It's much effect ratio.
It really doesn't like my word rates. And it's effort. There we go. And Theo, you wanted this word? But you know what, I heard you say it.
No, he said it.
Okay, then you know what it is. We're not doing that just for fun. Describe the rates in terms of some quantity produced or concern per unit time. We are going to then do some practice problems. Now, the first two, or the first one, this is going to be deliberately very easy. What I want to see is that you can show your work, and I can see all the calculation steps. So we're going to have a rate problem. The rate problem is going to be, well, first of all, let's do this properly. Please find your people. Etienne, you can join any group. Grab a whiteboard pen from over there and find a spot on the board. Grab your people. Grab your people. There's whiteboard pens on the side over there. If there's none on a board, you're going to find a section on the board. Etienne, you can join any group. When there's leftovers like that, you're not actually leftovers. You're a free agent.
What's the question?
So the question, everybody got their people? Okay, the question is, and this will be, oh, so difficult, a car travels at 120 kilometers in 2 hours. How fast? This is not a trick question. This is not like a ha-ha, I'm going to do something. There is one thing that some people found a little tricky last day, but it's not that tricky. Also, the rules when I come around and ask you, the person who writes everything down cannot be the one who explains something to me. So if you're the writer, you don't get to be the speaker. What? No. We are doing... Hold it. Did it just disappear? I just wrote it. No, we're not doing that one. I just wrote it.
It was the 120.
Yeah, I was doing it. What just happened? It just erased off the board. A car... Forget car. I'm going to make it my van. My van travels 120 kilometers in 2 hours. Speed. I want to see all the units. Incorrect close-up. Incorrect close-up. I like all the units. Units are good. Incorrect though. I need to see your calculations.
You said it's not right.
Got calculations, got units, good. Incorrect though.
What is that second word said?
A van.
Oh.
Yeah.
Oh. No, because 120
Ooh,
miles per hour.
Theo's got it.
is going-
Van goes.
What was the mistake in your thing?
No, I think you just want
Sig
us to write
figs.
it out.
Sig figs.
Wait, can we read this sentence? No.
Oh, that's awesome. I love having this sentence because that makes it really clear. But yeah, Theo has the correct answer if you want to check.
Oh,
Yeah.
6
Yeah.
point, no, 6. Just do 6. Erase 0.
Hey.
X 6 times 10.
So you do need to correct your answer though.
Kilometers per hour.
Did you correct it to yeah, sig figs good? Do sig figs good? No. There's no
one sig
sig figs. That's so interesting. Still not correct.
Yeah, it's
No.
Looking beautiful. Beautiful. It's
But it's
then both answers are
speed like that.
what?
that looks beautiful. Still has the incorrect numbers. You're allowed to look at other groups. I you don't understand the go sister.
Oh, you're right. 6 times 10 is enough for sig figs.
That, I like the work layout. You've got your units there. It's great. You have incorrect 64, and now you're 64.
No, but you're dividing by 2 hours. 2 hours is just once.
Actually, it just feels so
We just have to wait for some people to argue it. Good. Oh, good. Good. Nice.
Good job, guys.
How many things? The reason that it's a problem is that it's bad form. You never want to leave. You want to be really clear about how many sig figs it is. So what would you do to make that really clear?
Oh, like 6 times 10 to the 1.
Ooh, good. There you go. Okay, next question. Mr. Snow's car, because he has the coolest car on campus, travels at 45 centimeters per second. How far does it travel in 2.0 minutes? Please switch who the writer is. It shouldn't be the same. Oh, no. Yeah, God. What am I doing? One second. Don't do this question yet. New groups. Find your new people. Ashley, you're a free agent. You can join any group you want. New people. Okay, everybody have their new people? And I would ask that if you were the writer last time, you're not the writer this time. Okay, there's your question.
That's
2.0 minutes.
Yeah, 2 minutes. I can't explain. 120 times 45 is 5.
That makes sense. Then you just divide the 2 minutes. So you probably change the 2 minutes.
Oh, that's easy.
Yeah.
Change the second.
Yeah. And then take away second.
No, you want to divide 120.
Yeah, that makes more sense.
What's that?
2 minutes.
Is it 45?
5 from the 6 minutes. Sure. 45 times 120. 6 figs, 2 sig figs, so 45 times 10.
What's the centimeters?
Once you show me your answer, you can go. The last question on the sheet that's written there in black and white is for homework. You guys are good?
Yeah. Is this what or is this 40? Is this right?
The last question on the first page. Exactly. And a reminder for just independently that a surprise quiz can begin some classes on the material that we did last day.
Wait, so you have English next, right?
Okay, so you know we have to like you have to go to classes. really major. You got a demo. We're gonna have a lab. I think next week probably. Oh, I haven't assigned any questions. How's Jimmy? Go down and start.
So what is
The last question on the first page. That question.
that?
That question.
So this is not homework.
Yeah, I have homework yet, unless you want to get a head start. The last question on this page is the homework question. Yes, but email me for this check. Because I'll do it this afternoon.
Seeing you, thank you.
You're welcome.
I don't need nothing except thank you.
You're welcome. I'll try and put like the first 100 pages up so you have more than that.
Yeah.
What is it now? Is it break? I should probably go up and check. You're welcome. Oh, and I should stop the recorder.